Here we're going to do some more notes over vectors, mainly showing you how to do some of the word problems where you have to find the resultant vector and also find the angle between two vectors. So remember from before, a vector has a magnitude and a direction represented by a ray, and you can rewatch the other video if you want some review over that stuff. But what we talk about here is this parallelogram law, is when you're adding two vectors together, one way to do that is use this parallelogram. So if you have a vector v and a vector u, if you want to add those vectors together, that's drawn in the parallelogram. So a vector parallel to u and then parallel to v, and then the length of that diagonal would be the u plus v vector right there. So what we'll do is, I'll show you how to do this from scratch in a second. We're going to be given two vectors and probably the angle between the two vectors. And if I want to find the resultant vector of adding up those two vectors, we'll say, hey, this guy up here is going to have the same length as u, and this is going to have the same magnitude, the same length as v. And if I give you this angle here, what I want you to remember is that this angle here plus this angle here, these two adjacent angles add up to 180 degrees. They're supplementary. So if I tell you that this angle is 80 degrees, that means we also know this is going to be 100 degrees right here, because those two add up to 180. So just kind of keep that one basic property from geometry in mind. And let's just do an example with this parallelogram law, okay? So that, IU likes to throw problems at us like this. So we have two vectors, and then one vector has, now this is the magnitude of those vectors. So that's the magnitude of those, the length of those things. And it doesn't matter which order you draw those in, but they say one vector is 8 kilograms. And then the other vector is 11 kilograms. And it says the angle between the two vectors is 60 degrees. So this is 8, this is 11. And it doesn't matter if you switch those around, but the angle between those vectors is going to be 60 degrees. So that's what we're given. And then what us wants to do, it says find the approximate magnitude of the resultant force if the angle between those two vectors is 60 degrees. So the resultant vector, we're going to apply this parallelogram. So I'm going to draw in, so something parallel to this 11. So I'm going to draw in a parallelogram here. So that means this side is going to be 11, and then something parallel right here. This side's also going to be 8. And when I say find the resultant vector, that means that's the length of this diagonal right there. Okay, so if you call that C, and I want to find the magnitude of that C, I want to know how long that ray is. That's what we're doing here. Now, if you think about it, this is a triangle right here. So look at remember what we said a second ago. If this is 60 degrees, these two angles add up to 180. So if I go 180 minus 60, that means this angle right here is 120 degrees. And if you look at this picture here, we have this triangle where I have an angle and I have two sides, and I'm asking you to find the third side of that triangle. So if you wanted to zoom in on just that one picture, we have this is 8, we have this is 11, and we have this angle is 120 degrees. And what I want to calculate is the length of that segment right there. Okay, so you just have a triangle, and then as you look at this, when you solve the triangles, you're talking like law of sines, law of cosines. Remember, you can use law of sines if you have an angle and an opposite side matched up, but you don't have that. This is a clear law of cosines problem, and so we'll be using this a lot in the homework. But you're going to use your law of cosines from the last section from your 14.2 stuff to kind of find the length of that triangle. So let's review the law of cosines. We're going to go c squared equals, remember how that pattern works there. It's going to go 8 squared plus 11 squared. So this side squared plus this side squared minus 2 times this side times this side. So times 8 times 11. And then you're going to do the cosine of that opposite angle, which is 120 degrees. And so you want to know what is a c equal to. So you're going to square root both sides. So you're going to do the square root of all of that stuff right there. So let's kind of just do that in the calculator together. So I'm going to hit second square root, and I'm going to go 8 squared plus the 11 squared minus 2 times 8 times 11. And then I'm going to do the cosine of 120 degrees. Hit enter on that, and that's going to give us that the C is going to be, we're going to round this to the nearest 100 here. We're going to get 16.52 for that answer. So that's the resultant vector. If you add those vectors together, it's the length of that diagonal right there. So you just got to set it up. And the common mistake is sometimes people just ignore the whole angle thing. They just use the 60 degrees right there. You got to use the supplement of that. So draw a picture And then make sure you know what angle you're supposed to be using and how you're supposed to find that side. But it gives us more practice with that law of cosines. And that's really all that problem is. So model that when you're doing the homework there. Let's get those right. When we turn it to the other side of the notes, a unit vector, if you see that phrase, that just means the vector has a length of 1, a magnitude of 1. So let's do an example with this. It gives us a vector, not the full vector. I got to figure out this x value. It tells us we're in quadrant 3, and it does tell me I have a unit vector, which means the magnitude is equal to 1. That's the length of that vector right there. So I'm going to draw a little picture here. It says we're in quadrant 3, okay? So I know if I'm in quadrant 3, my x value is going to be negative at the end of this problem right here. So I'm going to just go a thing here and a thing here. So here's a vector in quadrant 3. And so I don't know what this x value is. So I'm going to need to find that, but I know that y value is going to be 3/4 there. So I'm always going to label my triangle with the positive values there. If you want to put the negatives in there, just be careful with that. But I just adjust my answers for what quadrant I'm in anyways. Now, if we tell you the unit vector is 1, that means the length of this hypotenuse is equal to 1. That's what that means when they say unit vector. So you could just, all this is a basic Pythagorean theorem problem. It's not difficult. It's not like crazy trig or anything like that. You just got to know how to set that up. So you're just kind of plotting that point right there, x 3/4. It tells you you're in that third quadrant there. So that's where I put my triangle. Always make it perpendicular to the x-axis. And then if you use your Pythagorean theorem, I'm going to go x squared plus 3/4 squared is equal to the 1 squared. And then this will give us x squared plus 9/16 is equal to 1. And then I'm going to get x squared equals, I'm going to make this, you could use the calculator, that's fine, but I'm going to do this without the calculator. I'm going to make this like 16/16, that's 1 minus the 9/16. So that's going to give me 7/16 for that. And I'm going to square root both sides. When you square root both sides, remember what you got to remember is you got to remember a plus or minus, but see, you're going to choose either the positive answer or the negative answer. And that's why the quadrant determines everything. If you're in quadrant 3, boom, that x value will be negative. And so you got to choose the negative. And when you square root the top, the square root of 7 is just the square root of 7. And then the square root of 16 is equal to 4 right there. But you got to be really careful with the pluses and minuses right there. So when you square root both sides, again, you got to remember the plus or minus, but you got to choose one of them. You're not over here in quadrant 4 and quadrant 1 to choose the positive value. You're in quadrant 3, so that means your x is negative. So just think about that real quick, and then that's just a pretty easy problem. And then the last thing that we're going to do here with the vectors, I know this says theorem on the dot product. What I want you to kind of jot down here, this is the formula to find the angle between two vectors, right? So we just want to kind of have this down, the angle between two vectors. The last thing that we got to talk about, last example. So I give you two vectors. I want you to find the angle between the two vectors. Now this actually says, we're not going to go the full way here, but it just says find the exact value of the cosine of theta. So the cosine of theta equals this stuff right here. So all I'm going to do is do a dot product over the magnitude of A times the magnitude of B, and then I'll have that down. And then we'll show you just for fun how to actually find that angle. You already know how to do that at the end of this problem there. But when I see something about the angle between two vectors or the cosine of theta between two vectors, that's when I know I'm using this formula right here. So the first thing I'm going to do is find the dot product. So let's just review that from the last section. So the dot product, I'm going to go 2 times 3 plus, I'm going to go 2 times 3 plus 4 times -5. And this will give us 6 minus 20, which is going to give us a -14. So boom, there's my dot product real quick. And then we also need the magnitude of A and the magnitude of B. And remember from your last video, your last note section there, the magnitude of A, the magnitude of the vector is the square root of A squared plus B squared. So it's just going to be the square root of this thing squared plus this thing squared. So I'm going to the square root of 2 squared plus 4 squared. So that's going to be 4 plus 16. That's going to give us the square root of 20. And I know I can make that 2 radical 5. Break that down a little bit. So that's the magnitude of A. And then the magnitude of B, you're going to do the same thing. Use your magnitude formula from the last section there. You're going to do the square root of this component squared plus this component squared. So we're going to go 3 squared plus that -5 squared. Make sure if you're plugging in the calculator, put that number in parentheses. This will be 9 plus 25, which would be the square root of 34. So once you do that, it's just a couple practice problems from the last section, then we're just going to have this formula right here. So we're going to go, let's say the angle between the two vectors, I'm going to go cosine of the theta equals the A dot B over the magnitude of A times the magnitude of V. So the dot product is what we found here, is negative 14. And then the magnitude of A, that's what we found here is our 2 radical 5. And then you're going to times that by the magnitude of B, which is the radical 34. And then we can simplify this. So this would be negative 14 over, and then if the numbers are both on the inside of that radical, you're allowed to multiply those together. And that's gonna, so this 2 I'm gonna carry down, and then 5 times 34, that's gonna give us 170 inside that square root. And then negative 14 divided by 2, that'll be negative 7. And then you got the square root of 170 on the bottom here. And remember, this is what the cosine of theta is equal to. And then if we simplify this and then that's what this asks for. It says, what is the cosine of theta equal to? And I got cosine of theta equals that. So this is technically my answer here. But then if we rationalize that, get rid of the radical in the denominator, you're gonna get negative 7 radical 170 divided by 170, and you should try to reduce those fractions, but that doesn't reduce any further. So if all the directions tell me to do is find the exact value of the cosine of theta, that's what the cosine of theta is equal to, and then we are done with that, okay? So sometimes they'll ask us for that. Sometimes we actually want to find what that missing angle is. And remember, if you want to find the missing angle, so this one doesn't ask for that, but if I had you find the angle, you would have to do the cosine inverse of that stuff right there. Actually, I won't even waste time simplifying it. If I had to find the actual angle, I would just take this right here and then throw that in to find that angle. So if we do the cosine inverse in the calculus, so if I do cosine inverse of, and I hit negative 7 divided by that square root of 170, that's going to give us 122. And if I round this to the nearest hundredth here, that's going to be 122.47 degrees right there. Okay, and that just means when you graph those two vectors, that's the angle between those two vectors. So if you looked at that real quick, you don't have to do this, but like the vector 2, 4 is just boom right there. There's my vector A, and then the vector 3, negative 5 is like right here. And then so that angle between those two vectors, that's what we just found is that 122.47. So if we just actually find the cosine of it, stop right here. That's it. That's the exact value. I don't want a decimal for that. We could always get a decimal for that if we ask for that, but I want the exact value of that. Stop right there. And if we ask you to find the angle, then you're going to stop right there. Thank you.